We're going to take up the questions from the Chapter 2 test. So the first question was a polynomial division of 2x to the power of 4 plus 2x3 minus 7x power of 2 plus 12x minus 2 divided by x plus 3. So just going to do a long division. 2x3 minus 7x2 minus 2 x plus 3. So I'm going to see what do I have to multiply x by to get 2x to the power of 4, and that's 2x to the power of 3 multiplied by x is 2x to the power of 4, and then I have to multiply it by the 3 as well. So then I get 2 times by 3 is 6x. Then I'm going to subtract it. This cancels out. This becomes a negative, so 2 minus 6 is negative 4x to the power of 3. I'm going to bring the rest down, 12 minus 2. So now I'm going to see what do I have to multiply x by to get negative 4x cubed. And I'm going to do the rest really fast. So negative 4 times by 3 is negative 7x squared. I'm going to subtract again. This cancels out. Negative 4 times by 3 is 12. So subtract it, become 5x squared plus 12x. And then I am going to multiply by 5x, which gives me 5x squared. And 5 times by 3, I get 15x. Subtractive cancels out. I get negative 3x. I still have the 2 here, so minus 2. So I'm going to do multiply by 3, get negative 3x. Multiply the 3 by the 3, get 9. Subtract it. And I'm left with a remainder of 7. So I write this as an equation. I say that this polynomial equation equals to x plus 3 multiplied by 2x power of 3 minus 4x to the power of 2 plus 5x minus 3, and the remainder plus 7. Now my restrictions are you can never divide a number by 0, so my restriction is what makes x plus 3 equal to 0, and that's if x is negative 3. So my restriction I should write as x cannot be negative 3. Okay, so question 2 asks, for what value of k is 2x minus 1 a factor of the polynomial equation 4x to the power of 3 plus kx2 plus 17x minus 7? So we have to find k when 4x to the power of 3 plus kx squared plus 17x minus 7 is divided by 2x minus 1. So if this is a factor and we get a 0 remainder, then we can find our b, which would be if 2x minus 1 equals to 0, then x equals 1 over 2. So this is our x minus b. So our p of b would be p of 1 over 2. So I'm going to plug that in to my equation. 4 times by 1 over 2 to the power of 3 plus k times by 1 over 2 to the power of 2 plus 17 multiplied by 1 over 2 minus 7. And if you solve this, you get 0.5 plus 0.25k plus 8.5 minus 7. And you solve for k, you get k equals negative 8. So when k equals negative 8, 2x minus 1 is a factor of this polynomial equation. Okay, moving on to the third question. Third question asks, the volume in cubic centimeter of a rectangular box can be modeled by a polynomial expression 2x to the power 3 minus 11x squared minus 41x plus 140. Determine an equation to represent the area of the base of the box in the height in centimeters is given by 2x minus 5. So this was a bonus question, but a few of you, I think, had got the right answer, just missed the part that it says it represents the area of the base. So the rare area, let's say we have a rectangle, the area of the cube is length times by width times by height, but the area of the base, which would just be a two-dimensional, so the area, I'll put a base for B, is just the length times by width. There is no height. Okay, so let's see what information we're given. So we're given an equation for area, which is 2x to the power 3 minus 11x squared minus 41x plus 140. And we don't have length, we don't have width, but we have height, which is given as 2x minus 5. Okay, and to get the area of the base of the box, which is what the question is asking, we need to find this, and for that we need length and width. So what can I do here? We did a lot of factoring, so I can see that if I had an expression for this polynomial equation that was a multiple of three things, I had 1, 2, 3 things being multiplied together, then I would have length, width, and height, probably. And my height is 2x minus 5. Okay, so let's first factor 2x minus 5 out of our equation. We do that by dividing it. 2x3 minus 11x squared minus 41x plus 140 divided by 2x minus 5. So I get, let's multiply this by x squared, x cubed, 5x squared, cancels out. This negative becomes a positive. Negative 11 plus 6 is negative 6x squared minus 41 plus 140. So minus 3 times by 2 is 6. So I need 3x to get negative 6x squared. I have to multiply that by the 5. 3 times by 5, 15x. 15x. Subtract it again, cancels out. This becomes a negative, so I have to add it. It gets a negative sign, so it's 56x. Bring down the 140. So negative 28 multiplied by 2 would give me negative 56. So negative 56x. Negative 28 times by negative 5 gives me positive 140. So this cancels out. Okay, so now I can write my equation for the area of the graph. I can write the equation for the area of the graph as 2x minus 5 multiplied by my quotient, x2 minus 3x minus 28. Okay, now this equation, now I know, is going to make up my length and width. So you could have given me this as my area for the base. So you could have said the area of the base of the box is, so 2 minus 3x minus 28. But you also, what a lot of you did is you further factored this, which you can do by x. I think it's 4, 7, that should work. There we go. So you could have further factored it, but it's important to note, you don't know which one of these is length and which is the width. So you could also tell me the area equals x minus 7 divided by x plus 4. But this is exactly the same as my just using this equation over here. And again, because we can't distinguish between length and width, there is no more information we can get by further factoring in response to this question. Okay, oh, and this was a bonus question, so I think it was a bonus 3 marks if you didn't get it. Don't worry too much about that. And let's move on to question 4. It says a box has a length, so let's write the information as we go. The length is x plus 5. The width is x minus 2. And the height is x plus 4, where all dimensions are measured in centimeter. The volume of the box, okay, great, we have the volume, so equals 144. Use a polynomial equation. Sorry, let me straighten. Use a polynomial equation to determine the dimensions of the box. Okay, so I can rearrange this information as my volume equals length times by width times by height. Now, to get these dimensions, which is what we want to do, we need to find x, right? And to find x, if I have an equation I want to find x, the easiest way is I need to get everything to one side to get a 0. And then I can maybe try factoring out so that I have multiples and I can make them equal to 0. And that would be the easiest way for me to find what x is. So I'm going to get everything to one side, and to do that I need to expand. So I'm going to first expand the first 2 brackets, x squared 2x plus 5x minus 10. So what I've done here is I've expanded it by multiplying. I'm sure you guys all know how to do that. It's plus 4, so this is x2. This becomes plus 3x minus 10. X plus 4 equals 144. And I have to now expand it with this. So you do that for each term like that. And I get x3, 7x2 plus 2x minus 40 eventually, 44. So I get everything to one side, and I get x3 plus 7x plus 2x minus 184. So that's just negative 40 minus 144. Now I have an equation all to one side equal to 0, nicely. Now let's try and factor it. So to factor it, I'm going to use the integral 0 theorem. I'm going to look over here. So my constant, and I don't have my leading coefficient is 1, so I'm just going to look at my constant. My constant, I'm going to write out the factors. It would be 1 times by 184, 2 times by 92, 4 times by 46. Yeah, that should be enough. And just also remember, it's both the positive and negative of all these factors that have the potential to give us a b value. So if I do these, I plug in p of 1, p of negative 1, p of 2, and so far I find that when I plug in 4, p of 4, so p of 4 is just when I put 4 instead of all the x's, so that's 4 to the power of 3 plus 7, 4 squared plus 2 times by 4 minus 184, I get a 0. So what does that tell us? That tells us that x minus 4 is a factor. Okay, so now I could divide this by x minus 4 and get the quotient, which would tell me the whole equation. But just having this enough, knowing that this is a factor, I can do x minus equals 0, and I can get my x value through this. Because the equation equals to 0, any multiples here, we make them equal to 0 and we can find x. So even though we don't know this p of q, even though we don't know that x minus 4 gets multiplied by the quotient, which gives us this entire equation, if we make this equal to 0 or this equal to 0, we can find x. So I already got an x value, so I'm going to go ahead and plug it in. So I'm going to do 4 plus 5 equals 9, 4 minus 2 equals 2, 4 plus 4 equals 8, and these are my dimensions of the box. Okay, So moving on to question 5. This was a bit tricky, I think, for some of you, but most of you were on the right track. So you're given an equation, 6x3 minus x2 plus 2x plus 1. So explain why this polynomial equation is not factorable. Okay, so we know that we can use the remainder theorem. We know that we can use the remainder theorem, the factor theorem, to use the x minus b to find factors. And we know that we can find possible factors using the rational zero theorem when the leading coefficient is not 1. I think this was, some of you forgot to look at the leading coefficient. So we said that when the leading coefficient is 1, you just look at the constant, but when it's not, you have to use the rational zero theorem and also look at the leading coefficient. So my b over a values now are positive, negative of 1, of 2, and of 1 over 2. So this gives me the positive, negative 1, and this gives me positive, negative 2. So 1 over 1, still 1. 1 over 2, that's how I get my 1 over 2. So these are my possible options. So to make sure that it's not factorable, I need to plug in all of these values. So p of 1, p of negative 1, p of 2, p of negative 2, p of 1 over 2, p of negative 1 over 2. So you needed to show that all of these, you had a value that was not 0, and therefore not factorable. Okay, so moving on to question 6. This was an inequality. You had an equation, x minus 1, x plus 3, 2x minus 5, and 6 minus x greater than equal to 0. So we said for inequality, so we just want to solve, but we just want to find the range at which this is true. So when is our polynomial equation greater than or equal to 0? So that's when our y value is greater than on the positive side, and because there's an equal sign, and also touching the x-axis. That's the range we want to find. So to do that, we said we first find all the x-intercepts. So 1, negative 3, 5 over 2, and negative 6. Oh, 6. Yeah. So then I usually like to draw my inequality, draw my line bar. Just helps me to visualize it better. So I do negative 3, 1, 5 over 2, which is just 2.5, and my 6. Okay, so this gives me my ranges, which is negative infinity to negative 3, negative 3 to 1, 1 to 2.5, 2.5 to 6, and 6 to infinity. Don't forget these two end ranges. Well, some of you had forgotten to put in the end ranges there. Okay, so now I want to see what's the sign for each of these separately, because that way, because of the multiplication property, I can add up the signs and see if it's positive or negative really easily. So to do that, first I get a test value. So for this, I'm going to do negative 4. For this, I'll do 0. I'll do 2. Let's do 3. Let's do 10. Okay, so for the first one, x minus 1, I'm going to plug in my test values and see if the sign is positive. I'm going to draw a line here. There we go. To see if the sign is positive or a negative. So negative 4 minus 1 would be negative. 0 minus 1 would be negative. 2 minus 1 would be positive. 3 minus 1 positive. 10 minus 1 positive. Now for x plus 3, negative 4 plus 3 be negative, 0 plus 3 would be positive, 2 plus 3 positive, well the positive values would just be positive, and 2x minus 5. So 2 times by negative 4, negative 8 minus 5, negative 2 times by 0, 0, negative 5, negative, 2 times by 2, 4, 4 minus 5, negative, 3 times by 2, 6, 6 minus 5 would be positive, 10 is again larger, so it would be positive. And the last one, 6 minus x, so 6 minus negative 4, positive, negative, negative would cancel out, 6 minus 0, again positive, 6 minus 2, positive, 6 minus 3, positive, 6 minus 10, negative. So now I want to see how this equation behaves when all of these terms are multiplied together. So I can do negative and negative would be positive, negative and negative would be positive, negative and positive would be negative, positive and negative would be negative. Negative and positive would be negative, negative and positive would be negative, negative and negative would be positive. Positive and positive, positive, negative and positive, negative, positive, negative, negative, positive, positive, all positive, so it's all positive, 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 negative, 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 positive, negative. So this equation says greater than or equal to 0. Greater than 0, that's the positive range, so we want the positives. So that is the range, negative 3 to 1 and 2.5 to 6. So to represent that, I'm going to write my x includes, and then write, this is again something you guys some of you missed out on, is because of the equal sign, remember it should be square brackets, and so do negative 3 to 1, and then union 5 over 2 or 2.5 to 6. And again, because of the equal sign, remember to put square brackets and not round ones. Okay, moving on to question 7 says, show that x minus a is a factor of x3 minus a plus b x squared plus abx. Okay, so we have a polynomial equation, our p of x equals, and we have the x minus a that's factorable. So again, we can use a remainder theorem and a factor theorem. So because based on them, we know that our b value for x minus b, so our b here is essentially a. That might be a little confusing, but our b is a. So then to do p of b, we do p of a, and I'm just going to sub in a for x. So a to the power of 3 minus the a plus b. So the x again turns into a to the power of 2 plus ab times by a. I'm going to put the a's I transferred it to. So if I do this, I can see that it cancels out. It cancels out to 0. And that means that x minus a is a factor. So essentially to show it, you just have to sub in p of a and solve and show that you get a 0 and it cancels out. So moving on to 8, and the last question, which asks you to factor a really long polynomial equation, 12x4 minus 17x3 minus 51. So I'm just going to do the first step, and you would be repeating it essentially until you cannot factor anymore. So the first step, do this. You can look at my 12 and get all the factors. 1, 12, 2, 6, 3, 4. Okay, and start subbing in p of 1, p of negative 1, and I see that p of 2 is 0. So that tells me that x minus 2 is a factor. And so I divide this whole equation by x minus 2. X minus 2, 4x5 plus 12, x4 minus 17, x1, x2. So I divide this, and then now I can use my equation knowing that x minus 2 and whatever quotient I get here, my p of q, equals this entire equation. Now, I can't factor this part further, but my quotient is probably factorable. So again, I look at my constant and my leading coefficient, find possible values, plot in the p's, find the zeros, find another factor, divide it, and then keep looking every round. And again, I look at my quotient and see if I can factor that further. And if I can't, I repeat the step over and over until I cannot factor anymore. So that was the review of chapter 2 test.